Hey everybody, as part of the 2023 update for the Deep Space course, I wanted to show you my latest workflow using the ZWO, AM5, and the ASIair. And as we discussed in the 2023 gear recommendation videos, I prefer lightweight and portable gear. In fact, I've got everything I need in this backpack, then I've got the AM5 here in this little carrying case. And my goal for today is to actually carry all this stuff to the top of a nearby mountain to see just how portable it actually is. As I start the hike, there's one other point I wanted to make. I'm just doing this for a fun video and to prove the gear is as portable as I said. And the reason I'm doing this is because maybe you want to fly to South America or go on a long road trip or something. Now you can see why I recommend this portable gear. It's much easier to take with you, unlike a Skywatcher EQ6R Pro and a Raza and all this other stuff that I might have. And for that reason, I think this portable gear is a great idea. Finally, there's no sense in actually hiking up a mountain with all your deep space equipment. You're not going to get any magically better photos necessarily. And you'd be much better off spending that time driving around in your car looking for a pull-off where you have a nice view of the night sky instead. And normally that's what I do. I either set up from the backyard nowadays and shoot in narrowband, or drive to a darker sky, set up right next to the car, and shoot all night long. After about an hour, I've made it to the top of the mountain. Unfortunately, I had to add this audio later in post because there's a couple mountain bikers driving around and they wouldn't stop. But now I'm going to show you what I actually have in my backpack. First up, we have the ASIair Mini, which I've been using the last few months, and it does a great job. I haven't noticed any performance issues compared to the more expensive ASIair Plus, so if you are looking to get a new ASIair, the Mini will save you $100 and do just as good of a job. And it's extremely lightweight and portable. Inside my main compartment here, I've got all of my cables and my Jackery battery. This is the only flaw with this particular setup that I brought with me, is that this Jackery battery is only 240 watt hours, which will not be enough to last the whole night. Realistically, I'd probably need a 500 watt hour battery, maybe even a 1000 watt hour battery to last me multiple nights. On the back, we have the ZWO AM5 tripod, which I'd highly recommend if you are thinking about getting the AM5. And in this side pouch here, we have my camera, which is the ASI 533 monochrome camera. The reason I love this camera in particular is that it has a very small sensor size, which magnifies the field of view of my little SpaceCat telescope, which I have in this lower compartment here. This SpaceCat is roughly the size of a 70 to 200 millimeter lens. Then I've got my auto guider and guide scope, which is the 30 millimeter f4. This does a fine job. And then last but not least in here, I have the filter wheel. This is the 7-position filter wheel with the 36 millimeter unmounted filters, which do an okay job, but as we talked about in the filter video, they could be a bit better in terms of the performance. I'm going to go through now and install everything up here on this little picnic table, and then we'll pick back up when I'm done. Here we have the AM5 in its little travel case. Everything I need is right here. And then what I can do is just attach this to the tripod and continue on from there. When I'm setting up the AM5 here, I'm always thinking about which direction north is in, because it would save me a lot of effort later if I can just get it roughly aligned to Polaris, or where I think Polaris is. Then I can install the little bracket down here and make sure everything's securely attached. Next, I'll attach my telescope to the AM5, and you'll notice there's no counterweights. That's another benefit to the AM5. I don't have to lug those counterweights around anymore because the mount is powerful enough to overcome most weight imbalances. And then from here, I'm going to install a dew heater on my telescope. As we talked about in the accessories video, this is something that I'd highly recommend everybody go out and purchase. They're only like 15 bucks on Amazon. This will not only keep your telescope from getting fogged up at night or frosted over, it will also ensure that the focus really doesn't shift as the temperature cools. So it has two big benefits. And the only problem is it's kind of a pain to install with the little handlebar there attached to the SpaceCat telescope. When I've got that installed though, now I can begin connecting all of my cables, which I'm assuming you know what to do by now. Basically, I just attach a USB from the filter wheel to the back of my camera. Then I connect a data cable, or rather USB 3.0, from the camera to the ASIair. And we also have this power output from the AM5, which is really nice because that will power the ASIair. I don't need a second battery or anything else. Anyway, you get the idea here. Attach all of your cables, and then from there we're going to install the ASIair Mini in this case. I do have to put a word of caution here because every time ZWO watches one of these videos, they always email me and say, hey, don't attach your ASIair there. There's probably going to be an issue with the telescope hitting it or something similar. Therefore, I do have to give you this caveat that ZWO does not recommend doing what you see here. However, for me personally, I've never had any issues, and this is the simplest and best way to mount it as far as I'm concerned. But if you want to do things in a safer method without the risk of accidentally ripping everything apart, then you might want to attach the ASIair to another location, maybe to your telescope or onto the saddle, something like that. With all of my cables connected, I can now turn on my battery and then turn on the mount. Finally, I should double check that the latitude on my base corresponds to my current latitude, which is roughly 48 degrees north. And that'll just help make the polar alignment steps easier later on. But there we go. In about 5 minutes, I've got everything set up and ready to go from it being fully packed up in my backpack. My mount is roughly aimed up to north. Now all I have to do is wait until it gets dark. So I'll pick back up with you guys once it gets dark, and then we'll go through my full workflow using the latest version of the ASIair. Alright, we are now ready to begin our nightly workflow. And I want to stress here right at the start that I'm going to show you exactly what you need to do, but there's always a chance that when you're going through on your own, you're going to encounter random problems along the way. It happens to me occasionally as well. So you may need to do some troubleshooting on your own, but hopefully you don't have too many problems. We're going to start off by making sure the ASIair and the AM5 are actually turned on. Then we'll go to our phone or our iPad. We'll go to the Wi-Fi settings, and we'll wait until we see the ASIair network. There we go, it finally showed up. And if you need to connect to this for the first time, the default password is always 12345678. When you first connect to the ASIair network, make sure that you choose Always Connect, or go into the settings and verify that Auto Reconnect is turned on, etc. If you don't do this, there's a chance that when your phone or iPad detects a stronger Wi-Fi network, like your home router, it will try to connect to that all the time, and it won't stay connected to the ASIair, which will cause problems. Anyway, now that we've connected to the ASIair network, we can start up the ASIair app. Most likely, if you haven't used this in a while, it will go through and do a firmware update, which will take about 2 or 3 minutes. But when that's complete, we'll click on Enter Device, and then move on with the workflow. The first thing we want to look at is the mount, which of course I'm using the ZWO AM5. That's all I have to do, but if you're using another go-to mount, you would just choose that here from the list, as close as you can find it anyway. And if you're using a star tracker, you're going to use on-camera ST4. When you've got your mount selected, we can move on. Then we have the main scope focal length, which is currently set to 249 millimeters. You need to input the actual focal length of your telescope. In my case, it's 250 millimeters. If you're not sure what your focal length is, just Google it and make sure it's correct. If you have no idea and you're just kind of stumped, put 0 and it will figure it out for you later. Then we have my main camera, which, as we talked about, is the 533 monochrome camera. So that's good. Normally, this is all very easy to do. If something is not showing up here, just verify that all the cables are plugged in. Maybe even just unplug them and replug them in. That might solve that issue. Next, I want you to look at the latitude and longitude on the left. This should correspond to your current location, but I've seen where often this will encounter some problems. Therefore, I'd recommend you use another app on your smartphone, whether that's Google Maps or whatever. to figure out your precise latitude and longitude. That way you can input it there. When everything looks good, we'll click on enter. This brings us to the main shooting interface, but it's very cluttered. So the first thing I want you to do is clear up all this stuff. And if you look over on the left, there's like a green histogram and a guide button. If you just tap on those, that will get rid of them. Then we have the go-to mount controls here. I can click this little arrow and get that out of the way. There we go. This will make it much easier for us. Now that we've got our interface looking halfway decent, let's go up to the top settings, and I have to adjust my electronic filter wheel. Because I'm shooting with a monochrome camera, I've got 7 individual filters. And because this is the first time I'm going through on the Mini with this particular firmware update and my phone, it doesn't know which filters are in which position. So I need to do this manually, unfortunately. I hope you have your filter list written down somewhere. Otherwise, you're going to be in for some serious problems here. But in my case, I found my filter list, and now I can update that here in the app. This would be one of the benefits to using a color camera, as you don't really have to worry about this step. But for me, I still love the flexibility of having a monochrome camera, even though occasionally it's a bit more difficult. There we go though, my filters are now set correctly. That'll go a long way to helping us out throughout the night. And it's always a good idea to have a note somewhere on your phone that actually has all your filters listed in case you actually lose the piece of paper. Okay, let's go back to our main shooting interface here. And we're going to start by clicking that circular button on the left with a 3-second long exposure. Keep in mind, I have the Batinov mask on the front of my Space Cat. That way I can focus right here at the start of the night. We can't go any further in the workflow until we know our stars are sharp. And as expected, the focus is still pretty rough. So I'm going to go to my focus ring, turn it a little bit, noting the direction I actually turn the focus ring, then I'll take another photo. I realize that there is a focusing tool built into the ASIAir software, but frankly, I don't really recommend it. It's not as good as it should be. I think that the preview option here is a much better way to do things. Anyway, this is just going to be kind of tedious. I'm not the best at focusing, so I'll pick back up with you guys when I actually have sharp stars. Before we move on, there's one other thing I wanted to mention, and that is I'm currently focusing with my L filter, which stands for luminance. Realistically, I'm probably not even going to shoot with the L filter tonight. So when you're doing this, it's probably not a bad idea to focus with the filter you plan on using, whether that's RG or B or one of your 3 narrowband filters, because the focus will shift as you go from filter to filter. Alright, and I'm back. I've got my telescope focused, at least close enough for the next part of the workflow. Now I can take off my Batinov mask. That way I actually have sharp stars without the diffraction spikes. And then I'll take one more photo just to verify everything looks good. There we go. It's a little bit hazy tonight, but that's the best we can hope for. With our telescope focused, the next part in the workflow is to do our polar alignment. And this would be a really good time for us to take a step back from everything, crouch down and look behind our AM5 mount or whatever mount you have, and verify that you see the North Star right over the top of the telescope. If you're pointing to the left or the right of Polaris, now's the time to pick up your tripod legs and rotate everything slightly until you're as close to Polaris as possible. If you forget to do this step, you could spend upwards of 30 minutes here troubleshooting just because you didn't realize you weren't even pointed towards Polaris to begin with. So this is a really important tip. Now that you've got Polaris centered right over the top of your telescope, you verify that your latitude matches on the base. We can go back to the ASIAir and change from preview to PA for polar align. I recommend doing a 3-second long exposure, and then we'll click the play button. It will now go through and take a photo using your main camera and your telescope, and it will detect some stars. When we click on next, it's going to automatically rotate everything down about 60 degrees, take another photo, and if it could plate solve that photo as well, it would compare the 2 images and see how the stars are rotated. Then from there, it's going to tell us our total polar alignment error. Finally, we'll click on Let's Go, and we can now see our total error there on the right. Another really important tip for you guys is that those circles in the middle of the screen are very misleading and distracting. People spend too much time looking at that and not at the numbers over on the right. I don't even look at the circles, to be honest. Anyway, we have 2 numbers there and 2 arrows, an up and a right arrow. Let's start off with the up arrow because it's so far off. Apparently, I did not have my latitude set correctly. It's still set for Canab probably. So what I'll do is I'll turn my altitude adjustment screw on the AM5. And because I'm 10 degrees off, that's pretty bad. I'll probably have to turn that thing probably 10 or 11 times at least. When I think I've gotten my altitude dialed in as close as I can get, I'll click on the refresh button here in the app. It will then go through and take another photo and update the total error. Now it's a bit better, but it still needs some work. So you get the idea. You make some adjustments on your base, take another photo, see what the score is, and just repeat these steps until your total error is as low as possible. This shouldn't take you more than 5 or 10 minutes at the very most. Normally, I get this done in about 2 or 3 minutes tops. And really, the amount of time it's going to take depends on the accuracy of your altitude and azimuth adjustments, because if you have really poor screws and they're hard to turn, then this is just kind of a nightmare. Another thing I want to mention is that if you can get your total error down around 5 arc minutes, that's normally good enough. The ASIAir won't be happy with you, but it's a real stickler for perfection. What I'm getting at here is that if you spent 20 minutes and you're just kind of chasing it and you're never quite there, that's okay. You can click on the stop button and just move on. But if you're the perfectionist, you can always go until you see the smiley face, which occurs if you're roughly 2 arc minutes or better. And it looks like I'm getting a bit rusty because today it took me about 6 minutes for a good polar alignment. So now that we've got our polar alignment looking good, we'll click on PA again in green and change it back to preview. Preview is always kind of our default workspace if we don't know where to go next. So we've got everything polar aligned, our stars are more or less sharp, that's good enough. Now comes the task of choosing the object we want to photograph. And for this, we'll click on the Big Dipper icon in the lower left. This is the Sky Atlas feature. And if you're new to the AM5 or go-to mounts in general, this is going to be a game changer if you've been using a star tracker for a while. Because now we can use our fingers here and just move it anywhere we want to. The way this works is that there's a blue square and a red square. The blue square is where we're currently pointed at with our telescope and camera. The red square is where we want to go. So if we drag our finger on the screen here, we can move anywhere we want to in the night sky. And if you are good at knowing the night sky and you know where these objects are at, you can just find things manually using this tool right here. That's the way I prefer to do things. For example, if I want to photograph the moon, I can get it centered up, let go of the screen, and then click on Go To there in the lower right. My camera and telescope will now go right to that position, and I can start shooting. It's that easy. If you don't know how to find your objects though, then just click on the Objects button there on the left. That should bring you to tonight's best. From here, just scroll down until you see a photo of something that looks familiar to you. Alternatively, if you don't see anything there, you can click on the search window in the top right corner, and then enter, let's say, Orion or Andromeda or something. As you'll see though, the app is still not smart enough to understand what Orion is, which is a shame. You have to know the M number or the NGC number or something like that, the more scientific names. For example, if I put M42, I think that's Orion, let's try it. Yeah, there we go. So I had to know M42. Hopefully we'll get that fixed in a future update, but that's something to be aware of. Another option is if you click on the 3 dots and 3 lines in the upper right, you can choose from a whole list of different categories, NGC objects, M objects, etc. Point being, there's a lot of different ways to find what you want to photograph. But I think for beginners especially, just stick with tonight's best. That's going to work just fine. Although, we do have all these videos here in the Deep Space course that show you how to find the objects overhead. So with that knowledge, you can always find them manually using the Sky Atlas feature I just showed you a minute ago. Now that we're here in the so-called galaxy season, which as far as I'm concerned just means there's no good nebula to photograph, I'm going to have to photograph something up north, maybe the Whirlpool Galaxy or Pinwheel or something like that. And for this, I'll just try to find it manually. There we go. When I get it centered up, I'll click on Go To, and now my AM5 are going to slew right to that spot. Before you click on Go To though, make sure you're out there with your mount, with your flashlight or headlamp turned on, because this is the time where a cable might get snagged or something else, and I want you to catch that as soon as it happens, if it's going to happen at all. If everything goes according to plan though, we can back out of the Sky Atlas, go back to the preview window, and then take another 10 or 20 second long photo. You should be able to see the object in the center of the frame. If you're not seeing it, you can always try changing your filters though. For example, if I was photographing a nebula, I might want to change to the H alpha and then take like a 60-second long exposure. That would allow me to verify that it's actually there in the frame as intended. While this photo is being taken, let's go back to our camera settings here and discuss those further. My gain is currently set to a value of 120. This works well for the particular camera. I have seen issues where if you use a gain that's too low, it actually has a really bad impact on your final image. And there's a lot of banding and other sensor-related problems. So in my experience with the dedicated astro cameras, it's generally better to use a gain of at least 100, if not more, whenever possible. The only exception would be if you're photographing something very bright, like the moon or Orion or something similar. I'd highly recommend that you do some research on your own though, to find the best gain for your own camera. Then we'll scroll down, and we see the cooler options. I always put my camera to minus 20 degrees Celsius just because that's a good round number, and that works fine. The cooler your sensor is too, the less grain will be in your photo, so minus 20 is a really good option. Next, let's go to customize file name, and I would recommend turning on all these different options. That's going to give you way more information when you get back to the computer. Now you know the camera that you actually used will be right there in the file name, as well as the gain that you used, and even the sensor temperature. The reason this is so important is maybe I'm coming back to the data 6 months from now. I'm not going to have any idea what gain or sensor temperature I used, but now that it's there in the file name, I'll never forget. And that'll allow me to take dark frames if I need to in the future. Finally, if we go back to the advanced settings, I'd recommend you turn off the continuous preview, as that will cause problems when you're trying to shoot here. Alright, if we go back to the main imaging interface, we can see, I think, the pinwheel galaxy here looking pretty good. That was a 60-second long exposure. We have now verified that the object is up in the middle of the frame. The next part of the workflow would be to focus our telescope even more precisely for the filters that we're going to be using. This brings up a problem though, especially if you're using a color camera with a narrowband filter, which would have been screwed in most likely. When I'm looking at M101, there's no bright stars here in the field of view. So if I'm using a narrowband filter, I'm not going to be able to see anything to focus on reliably. This is another benefit of having something like the AM5, because I can go back to my sky atlas by clicking on the Big Dipper icon. And then from here, I can find a nearby bright star. Whatever one looks good to me, maybe this one right here. Then I'll click on Go To. With this bright star centered up, I can now put on my bat knob mask again, change to my narrowband filter, whether that's H alpha or whatever. Again, assuming I'm actually going to use those filters tonight. Then I focus on that bright star. When I've got the focus dialed in, then I can go back to M101 or whatever it was I was photographing, click on Go To, and get it centered up, and then remove the bat knob mask. I hope this tip helps some of you guys out though, because I see a lot of people have issues trying to focus with narrowband filters, and this is a very easy solution to that problem. Moving on to the next step in the workflow, we've got everything focused, we've removed the bat knob mask, we've picked the filter that we want to use. We can now begin our guiding. I'll click on the guide button there on the left, it'll bring up a graph, and this brings us into another workspace specifically for guiding. This is very easy to do. We just click 2 buttons really. However, before we go any further, I want to make sure that your settings are correct. If you click on the graph button, you should see a deck mode there in the lower right. It's currently set to auto. If you do have a go-to mount, that needs to be on auto or you're not going to get good guiding. If you have a star tracker though, that needs to be set to off. Alright, now that we covered that, let's click on the begin looping arrows there on the right to start taking photos with our auto guider. You should now see something here on the screen. If you have not focused your guide scope yet, then it's probably just going to be a black or gray screen. This is why I stressed so heavily in the auto guider section here in the Deep Space course that you want to focus during the day. Then, once you've got your auto guider and guide scope focused during the day on some distant trees or something, you never take that thing apart, because then you have to refocus it at night, which is really a pain and takes a lot of time. And even though these stars are really poor looking, I mean that looks awful, it's going to be good enough for guiding actually, or at the very least for this tutorial. So my stars look good enough, I'll click the begin guiding crosshair button, and it will now go through and do its calibration. This will take anywhere from 5 to 7 minutes roughly. Then when it completes, we'll officially have begun guiding. While this is working though, let's go to our guide settings button up top here. And I want to talk about some of these settings right here. My calibration, max dec, and max RA are all set to 2000. That works well for me. I've turned off auto restore calibration. I find if you leave that turned on, it does cause issues. So turn that off. Beyond that, the only other thing I want to talk about is dithering. This is going to be critical if you're still using a DSLR, because a lot of us have color model and all kinds of other sensor related problems. For dithering, you just click on the switch there to turn it on. Then we have to choose the amount of pixels that it moves between each photo. This will mainly depend on your sensor's size and resolution, as well as the focal length that you're shooting at. Because I'm using a little tiny sensor and my effective focal length is around 700 millimeters, I don't want to move too many pixels, maybe 2 or 5. But if I was shooting with my full frame DSLR, I might want to go as high as 30 pixels here. Again, the way I want to think about this is that after every photo, the mount is actually going to move your camera slightly in a random direction. In this case by 1, 2, 5, 10, or 30 pixels. So if you have a full frame sensor with a wide field of view, you're going to need more dithering for it to actually do anything in the final image. I think we've got at least one video here in the Deep Space course that focuses on dithering in particular, so I'd recommend you watch that for more information. Ultimately, the main setting again is the pixels value. If you're not sure, just leave it to 5, maybe try 10. Just experiment and see what works well for your particular setup. The underlying reason we're using dithering, again, is to smooth out color model, to fix banding, to remove hot pixels and more, just by stacking our photos, because each photo moves a little bit in a random direction. If we go to the stability settings here, this ties in with the dither. So in other words, if I have a stability of 2 arc seconds here, that means my graph has to be plus or minus 2 roughly, or else it will not allow my camera to take another photo. This is another way of saying that if you want to have really sharp stars with no chance of any blur, you might want to lower the stability settings so it's even more accurate, maybe 1 arc second. Or if you don't really care that much, if you're shooting pretty wide, you can increase it to 3 or 4 arc seconds. That way you're not wasting a lot of time for things to settle down. But again, if you just stick with the defaults, that should work fine. We can back out of here. And it looks like our guiding calibration is still running, but it's almost done. When it completes, that yellow crosshair will turn green, and it should bring up the graph automatically. There we go. And now we see a red and a blue line on our graph. Red corresponds to your declination axis. RA is mapped to the blue color there on the graph. And eventually this should update your total error in terms of the arc seconds. For whatever reason, it wasn't doing it initially, but after a few minutes, it finally kicked into gear here. We can now see that even with those horribly focused stars there, my total guiding error is less than 1 arc second, which is really amazing. Yeah, now it's going up, but either way, it's still pretty remarkable just how well that's working. Let's move on now and begin taking our photos. We'll back out of the auto guiding window. This brings us back to the preview window. Then we'll click on preview and change it to auto run. This is how we can configure the camera to take the photos. We'll click the 3 dots and 3 lines, and this is our shooting schedule. If you have anything here, you might want to clear it out. Then we'll click on the plus button. And you're free to do whatever you want here. I'd recommend taking at least 2 or 3 minute long exposures, if not 5 minutes, regardless of the filter you're using, with some exceptions. Now, for me personally, I'm almost always shooting in narrowband lately, or even in RGB imaging. I still find that 5 minutes is a good sweet spot. It's not too bright, it's not too dark, and because I have really good guiding, there's still no star trails. I would not recommend shooting any longer than 5 minutes though. Moving down, we can change the filter that we're using, if you have a filter wheel anyway. Then we'll choose the number of photos. I'll do 12. The gain is fine at global gain, that's 120. Although that is a new update here, you can change the gain, which is kind of cool. Then we'll click on the plus button again, and we'll continue on adding our shooting schedule. If I'm doing a galaxy, I'm going to want to do R, G, and B. The only caveat I have with these 5 minute long exposures is that you're not really going to have that many most likely, which will cause problems with stacking. If you have more photos, that's actually better in a lot of cases. So there are times when you might want to drop it down to 2 or 3 minute long exposures and take more of them, rather than fewer 5 minute long photos. This is all stuff you just learn over the years and practicing, but for me, again, I'm almost always at 5 minutes for each one of my filters. That looks good. Over on the left, we have some really important metadata we have to fill in as well. The first is the target name. You can always rename that by clicking on it. Maybe call it Whirlpool or Pinwheel in this case, whatever is easier for you to remember. I'd also recommend you turn on that group by slot and the meridian flip. One of the nice things with the AM5 is that it handles the meridian flip for you automatically. It'll do everything you need it to. You can just sit back and relax. If you scroll down there on that left-hand menu, I'd also recommend you shut down the ASIair and go to home position at the end of the night. What that'll do is when you're finished taking photos, it puts it right back up to your polar alignment kind of stage there, the way you set it up initially. That way there's no chance of any issues for the rest of the night when it's completed. That means if I go to bed and wake up in the morning, everything's ready to take down. I can pull out all my cables, turn off the battery, and then bring it in the house. Okay, so we've got everything configured here in our shooting schedule. We can back out of it by clicking that button in the top left corner. And if your guiding still looks good, you can now click on the circle button to begin taking your photos. It's now telling us it's going to shut down and go to home after it's finished. That's fine. Then we'll click on confirm. And we have now completed the easy workflow using the AM5 for 2023. I would recommend you wait at least 5 or 10 minutes and check your first 2 or 3 photos and verify the object looks good, the stars are sharp, there's no guiding errors, etc. When you've confirmed that things look good, you can now go watch a movie, play video games, go to bed, whatever you want to do. And you know that everything is going to go through automatically and be taken care of. It's even going to go back to home and shut down when it's complete. So I hope you've seen today why I love using this setup. It's lightweight, portable, and really easy to use. And if you've been struggling with your own gear, maybe this will now give you some incentive to go out and start investing in a little bit better gear that's going to make your life a lot easier. But that's all I've got for you today, and I'll see you guys next in another video here in the Deep Space course. And if you've been watching the video on YouTube, then I hope you enjoyed it as well. I wanted to get this video out for free for everybody because I recently went through and updated the Deep Space course for 2023. I added probably 20 videos or so. Now we have over 120 videos to the Deep Space course. So as you can figure, it's very thorough, from the setup process to the ASIair to choosing the best gear, and I would say most importantly, your post-processing. I've seen where people have amazing data, but when they don't know how to process it properly, it just turns out pretty poorly. So we spend a lot of time talking about how to use PixInsight, how to use Photoshop in particular, to really take your images to a whole new level. And the underlying idea behind all of my courses is that I try to take all these really advanced topics and techniques and simplify them as much as possible. If that sounds appealing to you, you can check out my Deep Space course on howtube, which was recently updated. But that's all I've got for you today. Thanks for watching, and I hope you've seen today just how easy it should be for astrophotography.